Hello to everyone. I'm Irfan and welcome to this new session. In these lessons, I want to teach you how to simulate sensible thermal storage system in MATLAB. So let's start doing this. At first, I want to show you what's the diagram of this system that we want to simulate it in MATLAB. So imagine that we have got a tank like this and a heat exchanger inside this tank. So there is an inlet and outlet pipe to this tank. So the inlet is connected to a pump and also a heat source, something like boiler or whatever, solar collector, something like this. So we show it with HS, and this is a pump. And also in the outlet, kind of we connected to the system like maybe a heater or something like this, fan coil. And also there is a two outlets. One of them is going to heater to heat a house or something like this, and the other one is goes back to the system. Actually, this is for charging fast. And also for this charging, we have got this from the outlet of the heating system, which is installed in the house or in a place that we want to actually heat up a room. The outlet from these heating systems goes back to the storage tank. In fact, in the charging phase, we heat up the water inside this tank. For example, the volume is about, or the mass of this water is equal to 100 kilogram. And with C is 4.86 kilojoule per Kelvin. It's kilojoule per kilogram. So we achieve a heat from this system. It can be, we can use a boiler, which is that we burn a gas or gasoline, or we are using a solar collector and we store the heat inside this water, and then in other time whenever we have got no solar that we can use it, so we use this heat water inside this tank for heating in the house. So how we can to simulate this system inside the MATLAB? Let's do this. At first, we should choose our components. So as you see, we have got a tank, a heat exchanger, a heat source, a pump, pipe, something like this. So for doing this, we go to the SimEscape Foundation library and then thermal, and in the thermal elements, you can see several components. At first, for the our tank, we can use thermal mass. So we drag this to the workspace. It's a thermal mass. And also we need a convective heat transfer because we have got a heat transfer between heat exchanger and water inside the tank. And for thermal source, we can use, no, it's not necessary. And also in the thermal liquid, in the elements, I have to choose my heat exchanger. Okay, this is the pipe that we can use this pipe as a heat exchanger inside the tank. And also we need sources, flow rate source. Okay. And also for the element, we should use this. And also the other one. So let's connect it to each other. And here we can choose it's constant, the flow rate inside the systems, it's constant. And also, for example, the flow rate is equal to 1 kilogram per second. Okay. And the heat source for this system, we should connect it, this component to the pump that we can see as a flow rate source, and then connect this component to the heat exchanger. And also we use this component as a thing that we can transfer the heat from this pipe to the thermal mass, which is our tank. So I connect this component to this, and I name this to the thermal storage tank. So, and also connect this one. And for here, we need a constant block, which we can to set our value for this block and this one. So here, there is a point that we should to care about that. As I say that, here, there is a two connection. One of them is for the charging and the other one is for discharging. In the charging phase, actually, we put a fluid with a higher temperature to the system, actually, to charge this tank. And in the discharge, actually, we are going to use the heat inside this tank. So the temperature of the fluid which is go through to this pipe and this heat exchanger should be lower. So let's do this. Also, we can use this one because it's not necessary to actually change the temperature for this part. And for the here, we should go to the Simulink commonly used blocks and use constant and a switch and also a clock. Okay, so I put the switch here, and also I need a converter. So I go down, it's right here. I connect this to this one. Okay, it's good. And after that, I connect the clock to here, and I copy from this constant and connect it to this part. Okay, and at first the tank should be go to the charging fast. So I set this value about 360 Kelvin for charging. It's the temperature of the fluid which is going to charge this tank. And for the discharging, I set the value to 190. The temperature of the fluid is Kelvin. Okay, and after that, also I need an scope. Okay, and also another converter here. That's it. Okay, so again, go to the CIMScape thermal sensor. So I use the temperature sensor and I connect this to here, and the other one should be connected to this one, and I use the converter and then a scope to actually see the temperature of the displays of my thermal storage tank. And I set the value for threshold 1500, set the time 3000, and the mass flow rate. Okay, I should set the area of the heat exchanger, which is equal to 1 square meter. Okay, and also here it's the actually gross area for the heat exchanger, which is transferred heat from the heat exchanger to the tank. Maybe it's equal, can be equal to 1 or maybe a little lower compared to this pipe. And I said the heat transfer coefficient is 150 watt per Kelvin square meter. So I set the value for this, and 1 kilogram per second for the pump. That's it. And also, I forget something. Let's go to utilities, thermal liquid utilities, and connect this thermal liquid sensor to setting. As you can see, it's for water. Okay, and also we need a solver. So I separate to a solver. I use this, There's no difference where do you want to connect this solver to the system. So I think that's it. Let's start this system. Okay. That's it. Oh, I forget to set a value for the tank. It's maybe 30 kilogram. This could be good. I just want to show you how can you to simulate this system. And here you can see the temperature at the first point for the water inside this tank is equal to 300 Kelvin, and it goes to actually maybe 345 Kelvin up to 1500 second. In this time, the temperature of the water inside the tank is equal to this temperature, and then the charging phase stop, and then the discharge phase is getting started, and the temperature inside this thermal storage tank is reduced to about this temperature that we set it here. So also we can change the flow rate, and we can see what's the difference uh, between this one. Let's do this. Okay. Even we can change the threshold and set it to, for example, 3500. Set the time to 7000. Okay. Or even we can increase the volume of the water inside this tank. Set the value of 100 kilogram. And also I forget to change this. This is the specific heat of it's for the water. It's per joule per Kelvin kilogram. So let's start the simulation again. Okay. We can change it to 50 kilogram and then see. Okay. Actually, up to this time, we have got the charging phase and the temperature of the water inside this tank is equal to about 350 Kelvin. And then this charging phase is getting started. So that's it. It's good, and you can do it in your MATLAB and see and change the different value, different temperature, different threshold, different timing, different mass flow rate, or whatever you can do to see the different the behavior of this system. Okay, I hope that you hope this video. I'm waiting for your comments. If you have any question, you can comment your question for me, and I will answer to all of your questions. So good luck